What does an English physicist from the 1800s have to do with your electric guitar tone? Stick around and find out. Let's get nerdy. Capacitors are super cool in the electric guitar. It's not like it's new technology, but what they do is pretty hip. We use them in a couple of different ways. So what is a capacitor really? I have one here. It's two leads that are each attached to a metal plate. Now that metal plate has an insulator in between them, a dielectric, if you will, something that's non-conductive. A capacitor can be used to do a handful of things. One very common one is to store a charge. A battery is a capacitor. It stores electricity or stores a charge. A capacitor does the same thing. Capacitors, via the leads, can accumulate an electrical charge onto the plates in between them, creating an electrical field. So that electrical field or charge can be stored within the capacitor and released back into the circuit when needed. In the passive electric guitar circuit, we don't use them in this way. We use them as filters. What that means is it will allow or block certain frequencies from going on and through the signal path onto your amplifier to make rock and roll. There are a few common types of capacitors that we see in the electric guitar, and it's determined primarily by that dielectric material that I talked about between those two conductive plates. The most common for inexpensive instruments would be a ceramic disc, and you've seen these before. It's a little round thing, kind of rust-colored. Ceramic disc capacitors work. They do exactly the same thing as any other capacitor out there, particularly in this circuit that we're talking about here. It will filter the frequencies that we need it to do, and it will do just a fine job, and it's really, really inexpensive. We also see capacitors made out of polypropylene. Great big orange drop capacitors that you'd find in old Fender amps, and those are super cool. It's just a really good quality capacitor with high tolerances. Plus or minus, as far as its capacitance, it's going to be well within its own range. A really nice capacitor to use. Personally, I like a Mallory polyester capacitor. Finally, the other one that you see and hear so much about is going to be paper and oil. Those are typically handmade these days. You'll see them in vintage Gibsons, and they're recreations now, and they're super, super expensive. They look like great big brown resistors. But the more modern versions will have, their own logos and that kind of stuff on them. Also, a really, really great capacitor to use. Okay, so you made it this far. So you're now thinking, all right, Nutter, that's enough. Cool, you've got capacitors. How do they work and what do they do actually in the guitar? Let me show you. So we're gonna build on my little goofy illustration of the bucket last week. We got a water pipe. This water pipe is gonna represent our signal. Over here, as the water is flowing out, you can think of our pickup being this direction and this for the amp. Here, right there, that's our tone control. A big misconception is that your signal runs through your tone control. It doesn't. The tone control merely siphons off or filters frequencies from your main signal source. Our signal's flowing through here, all of it, every single bit of it. But right here, our tone control, we consider this little guy right here like the capacitor. Here's our pot. As we open that valve, some of those frequencies fall down onto the ground. That's why we get grass and flowers here, because I'm a hoot. Anyway, your signal continues to pass, but we can start to siphon off those frequencies. With the electric guitar circuit, what we're siphoning off are high frequencies. So we refer to this particular type of filter as a low pass filter, meaning the lower frequencies are allowed to pass while the higher frequencies are then bled off to ground. That's why as we roll down the tone control, we end up with a darker sound. Back at the very beginning, I asked you, what does a physicist from the 1800s have to do with your electric guitar tone? He's an English physicist. His name's Michael Faraday, and we use his last name as the unit of measure for capacitance. So we measure capacitance in farads. The most common capacitor values that we find in electric guitars are going to be 0.015, 0.022, 0.033, and 0.047. Those are actually measured in what's called microfarads. And you will see that after the number, and it kind of looks like a messed up U and an F. So if it's a 47, it'll look like that. on the capacitor. What does all of this really mean? The larger the value of the capacitor, then the more high frequency is going to be sent to ground. It's basically setting the ceiling for which high frequency can go. Here's another way that we use a capacitor in a passive circuit. Again, going back to potentiometers, and this is sort of a crude drawing of the back of a potentiometer here with my lugs 1, 2, and 3. I've got my ground here, so this is being wired as a volume pot. Remember I said as you decrease the resistance, then the less high frequencies allowed to pass. On your humbucker equipped guitar with a 500K pot, have you ever noticed whenever you roll the volume down just a little bit to clean it up, the signal gets darker? The reason for that is you've just decreased the resistance from its maximum potential of 500K or so to probably somewhere around like 350, 300, something like that. That means there's a certain amount of high frequency that's not allowed to pass. We can use a capacitor to help with this. If I take a small capacitor and I place it right here between terminals 2 and 3, with this setup, what this allows is as we turn down the volume and reduce our resistance, typically our high frequency wouldn't be allowed to pass. It would be sent to ground over here. But this capacitor allows a path for that high frequency to continue on. This is called a treble bleed circuit. The treble bleed allows you to retain all of that high end. Using this version, you need a tiny cap. So here we would need about 1,000 picofarad. As you roll down the volume, that high frequency can jump across this cap and head on out to your output jack. One drawback to this is that you can tend to be very bright as you roll the volume down. You can have a lot of high frequency going through. Experiment with this value. You don't have to stick with 1,000. You could go as small as like 220 picofarad up to about 1,000 or so, depending upon how much of that high frequency you want to hear as you roll the volume back. Another version of this, we could take a resistor and put it in parallel with this. So basically you're going to twist together the leads of the resistor and the capacitor and solder one to lug 3 and the other to lug 2. The reason you would do this is if you don't want that high frequency to dominate as you turn down the volume, the resistor will then sort of counteract that a little to help provide a little bit more balanced sound. The big drawback to this, if there is one, is that it sort of counteracts the sweep of the pot. This is another one to play with. So if you're using, again, that 1,000 picofarad capacitor, you should try something like a 150K resistor. Just like with the previous version, this isn't the be-all, end-all. You can mess with these values to see which ones are gonna work for you. Go as low as, 470 over here, up to about 1,000 or maybe even 1,500 picofarad. As far as the resistor goes, you could try 100K to around 330K. This is totally up to you. So the third version of our treble bleed circuit is to put the capacitor and the resistor in series. So as the signal comes in, it's going to be bleeding off that high end here, but this resistor, since it's in series, instead of having a negative impact on the taper or the volume control, it's going to help to keep all of that characteristic of the volume control. This is referred to as the Kinman treble bleed. If we use, again, our 1,000 picofarad capacitor along with a 130K resistor, Fender refers to this as their tone saver circuit. That doesn't mean that you have to stick with these particular values. Like the previous one, you can go from 470 up to about 1,500 picofarad and from 100K up to about 330K on your resistor. Those are completely up to you. Are those the only way you can use capacitors in an electric guitar circuit? Absolutely not. There's a lot of possibilities here. But within the circuit, primarily what we're using the capacitor for is for filtering. Folks will swear by one particular type of capacitor over another one. That this one sounds better, and this one's more lush, or this one has a squishier response, or this one's really harsh. These kind of things really do make a big difference to some people. To other folks, they don't make a flip bit of difference. So, take all of this with a grain of salt. Do know that they all do the same job and they all do it pretty well. Personally, I have set out on a rotary switch before, different types of capacitors with the same value. And as I clicked through, there may have been a nominal difference, but it wasn't really enough to make me think, man, that's the one. This is a to each his own kind of thing. Nerds, tell me, you guys, I know there's piles of you out there. What are your favorite types of capacitors? Which ones have you used? Which ones did you dig? Which ones did you not? Did you have one that was just like the be-all end-all, or another one that was like, this one's trash? I want to know, someday I'm going to figure out what to call that down there. Comment down there. Tell me about it. I want to know. Cool? So please like and subscribe. I'm going to take a break from the electronics thing because I realized that this can be a bit dull. Whenever I was lecturing this stuff at MI, watching them being like super jazzed to like full-on screensaver drool and the whole bit in like minutes. If there's a particular topic you would like to see me cover here, I would be more than happy to do it. Just let me know in the comments section below. That would be so cool. Did I just really call it the comment section and not go? I guess I did. Until then, I hope you guys have a great one. I'll see you guys next week.